These test engineers are checking out a sophisticated collection of telescopes, gyroscopes, and electronics for Project Apollo. This guidance and navigation system will be mounted in an Apollo spacecraft to aid our 3 astronauts on their voyage to the moon and return. The miniaturized computer at the very heart of this system is our story today on Science Reporter. I'm John Fitch, M.I.T. Science Reporter. Today, we're at the M.I.T. Instrumentation Laboratory, which has been given design responsibility for this guidance and navigation system, which will direct our Apollo spacecraft on the way to the moon and back. At one time, the direction of the rising sun, or perhaps the winding riverbed, was all that man needed in his restless search for a new land. Centuries later, the quadrant and the magnetic compass guided his way even across the open seas, even after familiar landmarks had long since disappeared. But today we speak of traversing 1,000,000 miles of empty space, where there is no north nor south, no rising nor setting sun, not even any up or down. It's an extremely complicated task requiring many, many measurements and millions of calculations. As you can see from this Apollo flight plan, there are several critical maneuvers that have to be performed. After the Apollo spacecraft reaches its Earth orbit, it must be injected into a translunar trajectory at just the right place in time and space. Someone has compared it to shooting at a moving target from a revolving platform which is mounted on a train which is going around a curve. Then at the halfway point, along about here, the programmed course must be examined for errors and possibly a mid-course correction made. There are many other similar maneuvers. And to learn about the guidance and navigation system which will make this possible, we talked with Mr. Eldon Hall, Deputy Associate Director of the Instrumentation Lab.
The guidance and navigation system consists of 2 measurement elements: controls, a computer, and a computer display and controls. The inertial measurement unit, shown up here but normally mounts in back, consists of gyros and accelerometers that measure the angles and velocity of the spacecraft in this fashion. The spacecraft rotates, the inertial measurement unit holds the reference so that angles can be measured. The sextant is an instrument very similar to that used by the sailors to navigate on the surface of the Earth.